Hi guys, and welcome back. So in the previous video, we took a look at how to establish a volume as part of a pod and then share that volume with multiple containers inside of a single Kubernetes pod. Now in this video, what we're going to take a look at is something known as a persistent volume. So what you may have noticed about the volume where we used an empty directory, we didn't actually have to specify any type of resource inside of Kubernetes except for the pod that we created as part of this pod spec file right here. So what we're going to do is actually explore persistent volumes a little bit more because there's a key difference here. So what you'll notice is that because in the previous video, the volume actually belonged to the pod spec configuration, so when we create the pod resource inside of Kubernetes with kubectl, then it's going to establish that volume and then it's going to share it with the containers. However, when we delete that pod, that volume is going to disappear as well because it's actually a child entity of the pod. So what we can actually do is persist data outside of the pod lifecycle by using a resource known as a persistent volume. Now, using a persistent volume is a little bit more complex because, as you'll notice here in the volume documentation, you actually have the ephemeral volume types have a lifetime of a pod. That's what we just kind of discussed a second ago. And so when a pod ceases to exist, Kubernetes destroys those ephemeral volumes. So that's what happened in our previous example, where when we terminate the pod, the data disappears with it. However, the difference with persistent volumes is that they actually outlive pods. So a persistent volume, unlike a standard volume, is actually a persistent resource that we can persist inside of the Kubernetes key value store. So what we're going to do is actually create a persistent volume, and then in future videos here, we're going to take a look at how to attach that persistent volume resource, which is just kind of a standalone resource that we can establish on its own. And then we're going to take a look at how to actually attach that to a pod using something else known as a persistent volume claim. So a persistent volume by itself can actually be established as a resource inside of your Kubernetes environment. And we can confirm that by simply going back to our Kubernetes command line utility here, so kubectl. And then if we take a look at API resources and then just pipe that into PowerShell's sort object command here, we can actually see, if we scroll up right here, there is persistent volumes as well as persistent volume claims. Now, what's interesting about persistent volumes is that the persistent volume itself is not a namespaced resource. So you'll see under the namespaced column, it's false. So a persistent volume is actually a cluster-wide resource that can then be consumed by pods that are running in any namespace. And the persistent volume claim is actually the link between the pod and the persistent volume that the pod wants to attach to. And what you'll notice about the persistent volume claim is that it is true under the namespace field, which indicates that the persistent volume claim is actually a separate type of resource that we can persist into the Kubernetes key value store. And that's responsible for binding a pod, which is also a namespaced resource, to a particular persistent volume, which is not namespaced. So we're going to be taking a look, first of all, at how to establish a persistent volume and then how to use persistent volume claims to actually link that over to a pod. But for starters, let's just go ahead and create a persistent volume. So before we actually create the persistent volume itself, it's important to understand a few different things about the persistent volume resource. So each persistent volume is going to be a standalone resource, as we discussed just a moment earlier, very similar to how pods and persistent volume claims are also going to be persisted resources. So this is actually persistent volume claims, so I meant to go right here under persistent volumes. Now what you'll notice is that, very similar to a pod spec configuration, we actually have a persistent volume specification as well. And so some of the different properties that we're going to be able to define, some optional here, are things like the capacity. So this is going to allow us to define how large we want the volume to be. We also can establish the volume mode, which we have file system right here. So we basically want this to be a file system that we can then attach to a pod. We also have something known as an access mode. And so for certain types of storage, like NFS network storage that can be attached to multiple consumers, you can actually configure it in read-write all mode, which allows us to essentially, so we've got read-write once, read-only many, and read-write many. So read-write many, not read-write all, rather. And so that's going to allow us to actually mount a particular volume as read and write by many different nodes. So depending on what type of storage you're using, if it's NFS storage or block storage like Amazon Elastic Block Store or something like that, it's going to determine which volume modes are actually going to be available. Because by and large, with some little exception on AWS Nitro instances, an Elastic Block Store volume is typically just attached to a single EC2 instance. So if you have two different pods that are running on two different nodes or two different EC2 instances, then you're probably not going to be able to attach that EBS volume to both nodes at the same time. They're going to start kind of fighting for it, and that's just not going to work out very well. On the other hand, if you're using something like NFS-based storage, something like the Elastic File System, EFS in AWS, then you could actually mount that EFS share to multiple nodes in your EKS cluster in AWS. So just keep that in mind as well. So that's kind of your access mode. So if we're doing something like EBS, we'll just use read-write once by one node that has read-write access to that particular volume. And then you also notice we have this option right down here called storage class name. And so with the storage class name, we'll get a little bit more into this later on, but it allows us to define a tier of storage that we would like to provision for this particular volume. So we could do something like magnetic storage or throughput optimized magnetic storage or general purpose 2, GP2, GP3 in AWS, or even IO1 storage. That allows us to define those parameters separately as a storage class, and then when we create the persistent volume, we can actually request a specific storage class name. Then we also have some mount options here that we can specify as well, which is going to, of course, depend on what type of volume we're mounting. And then even down here, you can see like we've got some NFS specific options as well. So what we're going to be doing is actually provisioning an EBS volume. So we're going to use the Elastic Block Store plugin with the read-write once access mode, and then we're going to later on attach that to this persistent volume that we're going to create to an actual pod by using a persistent volume claim. If we navigate over to this documentation here for types of persistent volumes, then you'll see that we have the option to link over to different types of storage here. And so what we're going to do is actually create an EBS volume. So we're going to be using this plugin for AWS Elastic Block Store. Now, when we click on that documentation, it's actually going to take us back to the standard volumes documentation. And this is going to kind of show us how to create a volume with EBS. And as you can see here, we have to actually pre-provision the EBS volume in this case, and then persist it as a persistent volume resource inside of Kubernetes so that Kubernetes is aware that that EBS volume exists and that it can be consumed by a pod. So for starters here, we're actually going to use the AWS Management Console to provision an EBS volume instead of the CLI tool, which you can see right here. So what we're going to do is just create a new volume with a couple of parameters, and then we'll actually persist that as a resource. Over in the EC2 console, I'm just going to go ahead and hit create volume. I'll just create a very small volume, something like 1 gigabyte, for example. That should be plenty for an example case. I'm just going to go ahead and use the default here, which is the GP2 storage. And then I want to make sure that I choose an availability zone. And as we discussed in the first video, I have two different worker nodes, one in the B and one in the D region. So I'm going to go ahead and choose the US West 2B region here. I'm not going to specify a source snapshot, although if I did have a pre-configured snapshot that I wanted to source it from, I could do that as well. And then I'll just go ahead and create that volume. So once that volume has been created, we get this volume ID right here, and now we can actually persist this volume as a persistent volume inside of Kubernetes, because at the moment, Kubernetes doesn't know that I just created this volume in my AWS account. We actually have to tell Kubernetes that it exists. So what we're going to do is go ahead and create a new file here, and we'll call this pv.yaml. And then I'm going to go ahead and type persistent, and you'll see I get this auto completion here from the extension. Just has some built-in templates here that make things a little bit easier to work with. And then I'll just call this CBT nuggets PV. That's going to be the name of our persistent volume resource here, and our API version is going to be v1. And then for our capacity here, we're going to specify 1 GI for 1 gigabyte, because that's the size of our volume. And then for our access modes, this is going to be read-write once because we can only attach this EBS volume to a single EC2 instance at one time. And then for our storage class name here, I'm going to go ahead and plug in, we're actually just going to omit that for now because we don't need to specify that, as we've already specified the GP2 type of storage in EBS when we created that volume. I'm going to go ahead and remove these options here. All right, so now that we've got this basic setup here for our persistent volume, let's go ahead and actually commit this over to Kubernetes. So we'll do a kubectl apply -- file name, and then we'll go ahead and do pv.yaml, and that should create our PV resource. Oh, of course, we also have to specify the volume type as well. So let's go ahead and plug in the AWS Elastic Block Store. And this is going to basically specify that we are going to be using the EBS plugin. And then we're going to plug in our volume ID right here. And that should be the only thing we need. I'm actually going to plug in our FS type here of ext4 as well, because that's often needed. We'll resave that, and then we'll go back to our terminal. We'll reapply that, and that should persist it to our key value store in Kubernetes. So now if we do kubectl get persistent volume, you can also just do PV for short. You can see that we've got this PV that's been imported into our cluster, and we can also just do describe on it to get a little bit more detail from it. And we should see that we have a volume right here with the Elastic Block Store type or plugin. And then our file system type is ext4 right here. The capacity is 1 GB. And so now Kubernetes is aware that this volume exists. And so we can actually persist it, or we can actually tie it over to a pod using a persistent volume claim, which we'll do in the next video. I hope this has been informative for you, and I'd like to thank you for viewing.